Ladies and gentlemen, please welcome our next speaker, Gabriel Manor, presenting the topic, the future of authorization and applications.
Can you see my slide? Oh, great. So I know that you come to hear about the future, but I'm sorry, I'm going to disappoint you. I don't know nothing about the future, neither any one of you. What I can do is try to predict future trends, but we need a framework to predict future, because if we're looking, for example, at a Back for the Future movie, we see today that many of the things there never happened and maybe will never happen in the future. So my name is Gabriel, and today I'm going to talk about a framework, how to know or at least predict what will be in the future, and specifically in the authorization field. My first credibility to predict the future is my work. I'm working as a software development since 2012, and somehow since 2015 I was around authorization. I work on products that do authorization in the network. I work on cybersecurity products on the authorization part. How many of you develop authorization in their life sometime? Yeah, that's many. That's great. Hello, friends. So yeah, authorization is something that is probably part of every product at some level. But in the last years, I found that there are some trends that we need to follow. And today I'm going to talk about it. I'm working in a Permit.io, a startup again around authorization, but I'm not going to talk about Permit, of course. I'm going to talk about in general the field, some open source tools. So let's get started. First, I identify 4 problems that we have today in authorization. The first one is the chaos. Every good authorization implementation today in applications, it starts without any kind of order. The second is the complexity of the permission we want to get in any application. It is not anymore an admin and a user. It's much more complex. We have too much data in our application to make it simple. The velocity in that we ship our software on, right? We are delivering software every minute maybe, and that's require permission change, and that require better authorization in our application. And the confidence that we want to have in our application. And let's dive into each of these problems in detail. So first one is the chaos. If we are looking back on a 2010, 2015, application used to be one piece of code, right? I remember when I started to work, our code base was 8 GB. We managed it as files. We deployed software as artifact, as one large artifact into not the cloud, into a computer somewhere in a server farm. But today our application incorporate many components. It could be microservices in a microservice architecture, but even in a monolith architecture, we are modeling our software in a way that we have multi-languages, that we have multiple third-party services that we are using, for example, for data, for monitoring, for observability. And in a way to streamline our permissions or our authorization service across all our components in our software, we are getting into chaos. An admin in one service can be someone else in another service. And it's not only that, even inside those services, we are getting data from multiple points. And that led me to the second part. The data that we are processing is not anymore a one database, right? When I started to work again, and I'm goes back again and again in time. But when I started to work, there was like a stack that's called WAMP or LAMP, right? We have PHP, MySQL, and Apache Server. And actually, we have one place to store all our data. We have one instance. It was vertically replicated into multiple instances. Today, when I'm starting application, I'm consuming data from many sources, some of them in-house, right? I have my NoSQL, my MySQL, my big data instances, my BigQuery, right? And I also have data in third-party services, maybe in Elasticsearch, maybe in some other providers that allow me nowadays, maybe LLMs. This data led to what I call decision fatigue. The more data that we have, the more decision we need to make. And this decision require more and more data in them to get calculated, right? The policies that we are running on our data needs more and more decision calculation, and that led it into decision fatigue, because we say, okay, we want to keep a less privileged principle, so we will not get this decision, we will not just allow it to a particular set of user, but that also create an experience problem, right? And then people just find a way to access or find a way to perform operations. So the data in our application also create complexity in what we have, and also we have the velocity, right? So we are delivering, as I said, software every minute, every couple of minutes. If you are a startup, we can deliver 10 times a day to production. Every deliver maybe have some permission changes, maybe have some configuration changes in the policies that we want to enforce, right? Where, for example, the admin can or cannot access. But also, if it doesn't have any kind of permission, we want to make sure that we not break anything in the data that actually used to calculate the permission request. And last is the confidence that we have in our software. And I think the main problem that we have in that is the user requirement. Unfortunately, the users of our software being sophisticated in technology from day to day, and they require some stuff, and they also understand security. So they come and say, hey, I want this permission model in my application, which not always possible, but you still need to provide that. And you still need to provide a good experience, because if, for example, I have an if statement in my code that decide what a user can or cannot do with a very special, specific assertion of variables, I want to streamline it to the user in a way that they can understand. Okay, I'll assign role to someone and then he will be able to do something. And this requirement also add a level of a problem in the way that we do authorization. It's not only that, there are much more users or stakeholders to our code and application, right? There is not anymore only developers that actually do something on the code. There are DevOps, there are platform, there are security engineers, there are maybe even RevOps. The BI people today require access to the code base because they want to add some analysis on the code and the application code. And we need to make sure that all these stakeholders do not break permission, but also get the relevant permission. I don't want my BI people get access to private user data, but I want them to get access to metadata of the users, right? So these stakeholders around our application create another problem on the way that we are actually modeling permissions. And for the last year, sorry, I'll go soon to that. For the last year, we have also tons of AI agent, LLMs, RAGs, a lot of services that actually require access to unstructured data in our application. And this unstructured data, we need to think on a better way we can give permissions for data that is not structured to any form in any other data in our applications. Just an example that everyone can understand is healthcare data. So back in 2018, let's say, before the COVID and all the digital health growth that we experienced, the owner of my healthcare data was the insurer company, maybe, right? The one that provide me the service. They has all my healthcare data and they own that, and I trust them that they give access for someone to that. Today I'm the owner of my data. I can migrate it between provider. I can ask for a very specific time that a nurse in an external place will get an access to my healthcare data, right? So the user requirement today in authorization is not what it was. 5 years ago, the user that required authorization would just say, okay, I want a different level for admin and a user. Today, even in consumer application, user want to know, hey, I need access to my data, but I want a possibility to share part set or subset of this data with other user for a limited set of time, right? So this user requirement create a problem of confidence on what we are sharing or not in our applications. With that problems in mind, we need to predict the future, right? So what is the best way to do? Then look on some other that experience problems and see how can I solve that. How can I know what will be in the future if I look on other problem in software engineering and see how do they solve back then and try to implement them in authorization. So one example I love to take example from is programming languages. Back in the 40, 50 computers became, people succeed to do something with silicon that can do calculation. And then they understood we are going to a new level, a level that we need to program these computers. So they invented, or not invented, it was like a evolution of the nature. They find the binary language and then so-called machine code, right? That was the first language that we use to program calculation machines. At some point in time, we have the problem of the chaos, because there is a limitation how much you can write in binary code, right? And how much people can read. So people started to create programming languages, high-level programming languages like C or Fortran for specific for specific usages. At some point around the 80s or 90s, this code became more complex because computer became very they were like everywhere, and these languages were too complex, and we started to create, not me, I born after, but computer science started to create languages that influenced by design patterns. So for example, C++ is a high-level language that had the design pattern to solve this problem of complexity. And C++ and after that Java and languages that influenced by design pattern started to have problem with velocity, but they solved that with this design pattern. Because if I'm creating, for example, an object-oriented language, I can deliver software much faster because I can create solutions that are fit for what I need to do now. And for different solution, I have different languages. At some point, we get to a point where this code is hard with confidence because it has performance issue, and I need to find or computer people need to find a way to have programming languages that are specific for something, solve a very narrow problem in a very good way, and which is scientific proof, or at least any form of proof that it has no performance issues, no reliability issue, etc. And then started to came domain-specific declarative languages. Some of the most hardest problems in computer science today solved with domain-specific programming languages. The main example is HTML. Now I know it's not a programming language, yet it solves very hard problem. How hard? This is how long it takes to write one div in assembly, one div in C++, and one div in HTML. So first, the level of the confidence in looking on that div, and I'm not speaking about the complexity the CSS bring, but the level of the confidence in looking at that div, you can compare it to the level of the confidence with some memory leak in any other language, right? And the velocity is very fast because it's a declarative language. It's just going again and again into production in a way that I can very easily measure how much I have a confidence in and velocity in my deliveries, and of course it's a high-level languages, etc. So with these four problems and the solution, like we want the structure for the chaos and etc., we will now try to see how can we implement that in authorization to create better authorization product. And probably these trends, some of them already exist, some of them exist but are not widely spread. But it seems like that's the way authorization solution going to look in the near future. This is just another example for domain-specific declarative language for areas that are need this to solve these four problems, not only HTML, of course. So first, let's see how we can solve the chaos by structure in authorization. So first, we need to think what are the level, and we are the subjects that we are authorized. If we're looking here in my right side, but your left side, we can see all the subjects that we want to authorize in our application. Let's start from the top. We have the end users. The end users, for sure, that's the main users that we authorize, right? This is the most traditional one. User in our application is someone that we want to authorize. It's the first subject to authorize. The second is internal users, but somehow developers. So we have internal users in our applications. For example, the RevOps in the organization or any other internal stakeholder that want to configure permissions. These are also users that we want to authorize in a lower level than the end user, but we still need to authorize them. With all the service to service and microservices in the cloud, the services that interconnecting each other in ingress also need a level of authorization. We want to create policies that also authorize services to do not connect and to do not perform things that they are not allowed of. So this is the third subject. And also a subset of services is also infrastructure as code. Since we are deploying in a very automatic way, in a very continuous way, we want to make sure we are streamlining our policies and permissions in a way that all our services and infrastructure as code incorporate in our authorization service. And of course, you can, I'll not go read everything here, but this subject is something to start from. We can have a structure of who we need to authorize. What are the subjects we want to authorize? After that, we can start to model how do we want our policy system to look like. So again, let's start from the left side. In the left side, we want all our subjects, all our architecture to be authorized with the same set of policies. In some applications that's hypothetic willing, but in some applications that start with a thing that we'll get to that later, like policy as code and policy as graph, we want all our configuration, the rules. So for example, admin can access all document, etc., etc. This one we want centralized in a way that all the services getting the same configuration. To get the decision based on these policies, we need policy engines, right? Again, in the abstract manner of policy engine, but we want them to be decentralized because services can be far from each other or in a different time zones or in a different geo zones, or just services that they're not supposed to get the data that related to each other. So we want the policy engine to be decentralized and then consumed by any part of our application. So the best authorization service architecture that we can have that is ready for the future has centralized configuration, decentralized engine that can consume by any part of our application that we saw in the levels before. Here, for example, if some of you are familiar with domain-driven design, in domain-driven design it's very easy to imagine that because we have the authorization domain, and the authorization domain has a subset of the decision engine in each one of the other domain, but only the engine. Part of the authorization domain is the policy data and the configuration of our policies. After we know how to solve the structure, let's look at the design patterns that we have in authorization. First design pattern is understand how authorization decision happen, right? Every authorization decision ends with a true or false value, right? We have a large something, and the result is allowed or deny. But what incorporate this decision? So there is three main parts. The first one is the policy. Think about it in the abstract way, like I mentioned, like admin can access all document, user can only read all document, right? This is the policy. Then we have the data. The data is, for example, the names of the document that we might want to calculate. What is the name, when the document started, etc. And then we have the context. Context is the real-time data that drive the decision. So for example, what is the time now? Let's think about an example. So we want all admin to perform read operation on document that start with the let's say on all the PDF documents, but only in daylight, right? So we have the policy config that allow the admin what we described. We have the data, which is the file type, and we have the context, what is the time now. Together, a policy engine that incorporate these three pieces, context, data, and policy, can return us a decision, right? So this is the main design pattern, understanding what incorporate a policy decision. Then we need to understand what is the decision type. So that's right, every decision type is allow or deny, but at some form we want also to do maybe data filtering. So if we want to read a whole table in the database, we want to return what a user can or cannot read. So some authorization decision could have more granularity than that just allow or deny. Maybe it's allow or deny on a subset. And also, if we are thinking about the enforcement point, we want to get something that looks like that, right? A check function, authorization, atomic authorization function that incorporate these three pieces, or actually here it's four, because we have the user, the subject, we have the action, what they want to do, and the resource, what they want to perform on. And then we also are able to pass some context, like what is the time now, or what is the time zone that the user application is using now, right? So this design pattern can solve us most 99.5% of the authorization decision that we want to make. So this is a great design pattern to start from. And if we think about it, we can take it even to a remote procedure call. So we can have HTTP call in our policy engine or in our authorization service that always get this argument as a pure function, always return the same value. This way we are streamlining one design pattern for all our services that consume the authorization service. Another kind of authorization decision that we might want to have is called partial evaluation. Partial evaluation is something that just started to form now, but it's say we have some query languages, right? We have SQL, we have GraphQL, we have maybe for big query, some form of query languages. What if we can, instead of getting a decision of what a user is allowed or not allowed, we can get a query that is fit for the specific user. So for example, if an admin can read PDFs on daylight, instead of returning allow or deny, the policy engine will return SQL query that fit only to that, right? That filter the relevant data. And then we can make sure that when we fetch the data from the database, we get only what we want. So this is another design pattern. It's less common than the just check function, but it's something we want to consider. Now, after we have some design pattern how we code should look like, let's talk about the velocity and how to solve that with framework. This is the part that some of it not new, some of it is fairly new, but the main framework we have in authorization today are for everything is end with a back, which is based access control for sure. So we have policy-based access control. We'll get to everything later, no worries, and not just continue. Role-based access control, attribute-based access control, and relationship-based access control. Let's start from what's so-called coarse-grained authorization. Policy-based access control say, I do not have too much data to make calculation of. I do not have too much context to make calculation of, but I do have complex policies. A common use case for policy-based access control, if any of you use infrastructure as code tools that check if the infrastructure as code is actually standing security standard, they are running policy-based access control. They have, for example, a rule that say only developers can create S3 buckets in AWS, right? So only they can deliver CloudFormation or Terraform file that include creation of S3 buckets. This policy decision does not require any kind of data. The subject is on the request. The action is clear, create. The resource is S3 bucket, right? So this is driven by policy, but it's hard when we need to incorporate data to it. Another form of coarse-based access control is coarse-grained authorization is role-based access control. This is the most common one, is a synonym. Many people just call authorization role-based access control. Role-based access control is good. It has very good experience because we can say this user has a role of admin, this user has a role of admin and a moderator, this user has a role of user, and then we drive the permission by the roles of the users, right? So we determine what kind of permissions user will get by their roles. Still, it's very subject oriented. If, for example, we want to have a level of granularity on the resources, so for example, we want to say only admins can access PDF files, it's getting harder and harder because we are bringing more variables into the policy decision, and that getting RBAC complex. And it's actually why RBAC consider coarse grain, because we cannot have fine grain granularity on the permission that we are getting. This is an example, very simple example. In a healthcare system, we have Rick and Morty. Rick has dental member and mobile agreement roles, and it gives them some permission in a very specific resources. And we also have Morty that has paid users. But what we have here is not enough in a world full of data, in a world that we want to have fine-grained permissions. And this is where attribute-based and relationship-based access control get into the picture. Both two models calculate also the resources in the way that we are getting decision. What is relationship-based access control? So every entity in our application has some relationship with something else, right? even if you look on relational database, is easy to imagine. But at the end, even if you look on abstract API endpoint, so API endpoint are belong to some form of same authentication or belong to some form of same resources, has some ID that you can connect with other IDs. What if we can take this relationship, assign one resource to one user, and drive the permission by it? What if we can have a long set of access control lists that say Gabriel has this document, so they allowed. Gabriel has the other folder, so they allowed. It is not enough, right? Because it's only one relationship, so we have like giant relationship-based access control. And this is exactly the problem that Google found. Because if you think about Google, Google is one of the most multi-domain companies of the world. They have enterprise products, they have cloud products, they have a media product, they have advertisement product, tons of product, all has one identity. Now, just look, for example, something that I experience from the perspective of authorization. Let's say that I have my business Gmail, I have a Google Ads account where I manage my ads, and I also have a YouTube channel. How can Google determine that in my Google Ads account, I should have access to my private YouTube videos, right? The only way to do that is build like a giant graph of all the relationship between resources and users in Google. And then Rebak can drive a so-called graph relationship or endless hierarchy or role derivation. There are many names to this one. Role derivation is the one that I mostly like, and that's actually said, if I have a role to one resource, so let's say if I have an admin role on one folder in Google Drive, then I get a derivation to all the folders and files that actually related to that. And that's the way actually permissions work in Google, because Google released a paper called Google Zanzibar, something that became very popular and drive a lot of fine-grained authorization implementation. Google Zanzibar is actually describe how relationship-based access control actually work. And the main thing in Google Zanzibar, the first one is relationship tuples. Every entity in our system is related to someone, right? We are modeling all our system in a giant graph, and each resource can belong to one or other entities. Second is role derivation. If I am assigning a user to one resource in this graph, I can also put the user in the graph, then they are derived the same role to all the other entities in the graph. After that, we have, of course, this graph that determine. And this access control list, what a user can do, instead of being access control of billions, being access control that narrow to role assignment, and the derivation is derived by the graph. And then we get a fine-grained authorization because we can have a calculation of every resource in the details for what user is allowed without explicitly assign them roles to these resources. I hope it's clear. Rebak for at the first point is something that sounds confused, and even my diagram is even more confusing than that. I'll try to go over it. So we have here the same Rick and Morty, and what we want to get in this healthcare application, we want to allow user access to different user resources. So for example, I want to allow Rick to access to a subset of Morty resources. Now in RBAC, if you think about it, I'll have to explicitly assign a caregiver role to Rick for every of Morty. Sorry, I always confuse between them. To each of the Morty plans, right? But in RBAC, the purple one that you see is an explicit assignment, but the red is actually a derivation. So if I am assigning one caregiver role, then because they are related in the graph, right, the dark brown arrows, if they are related, I can derive also the red one, the caregiver one. Rebak can sound again complex at the beginning, but after you use one of the implementation that actually exist, many of them as open source, we'll get soon to the specific implementation that I personally like, you'll get very simple, out-of-box, fine-grained authorization system. Another fine-grained authorization model is so-called attribute-based access control. Attribute-based access control came with the assumption that every entity in our software has attributes, right? Even in the world, everything has attributes, the colors, the place, where they locate, what is the time now, etc. What if we can get all these attributes and build condition sets based on them, right? I can assert one attribute. So for example, I can say if Gabriel if Gabriel role equal admin, so return allow. But what if I can create condition sets on top of this assertion, and then we can incorporate both users and resources as set. Instead of saying user role at one level of granularity, I can create a user set with many assertion, maybe even nested assertion, and assert them with the assertion that I'm doing the same with the attribute of the resources. Attribute-based access control is actually very common in some time-sensitive system because in Reback, we need to create this graph, right? We need to create the relationship. In attribute-based access control, everything can arrive from the context itself. We can get the data into context, and the policy engine will just get a decision. So attribute-based access control is built for decentralized system. It has some problems because we have to be very explicit with the assertion. What does that mean? So in Reback, because we have the graph, we do not need explicit assertion of the conditions. We can just have one condition equal to true, and then the graph will derive the permission. In attributes, we need them to be explicitly assigned to the attributes themselves. Here is an example for a specific role in ABAC that we are allowing user only between dates. And of course, the best thing, if you can afford it, is to combine RBAC, Reback, and ABAC together and balance between the experience, because RBAC, of course, gives the best experience. I'm just assigning role to user. Developer experience, that it's a little harder with ABAC, but easier in Reback, and also performance. Now that we understand, I have a little demo to show you that incorporate all the components, but I see that I left only 15 minutes, so I'll continue with the deck, and if we'll have time for demo later, we'll get to the demo. The last is the confidence. We want to get a confidence, and if you remember, programming languages solve confidence with domain-specific declarative language. Authorization today also have domain-specific declarative language. Let's look even, for example, on this one. So this is a declarative language that declare policy rules. You can see here two conditions. As you can see, this language is built of, first we have the subject, action, and resource, which we discussed is the best design pattern we can have for authorization. We also incorporate conditions here. This is a very simple condition, like a resource, we are checking what is the attributes in this resource. And there is also the ABAC condition, attribute-based condition, and we do assertion, right? What if we have this kind of declarative language that allows us to declare the policies that we want to have in our application? The good news, there are too many languages. The first one that I'll talk about today is a language called Rego, and it's used by Open Policy Agent. Open Policy Agent is a policy engine, a very famous one in the market since 2015. I was involved in Open Policy Agent from the first days. I must say that in 2015 it wasn't that great because instead of that we just wrote ourselves policy engine. But Open Policy Agent today is a mature product that can help you a lot with doing policy decisions, not only authorization, but we'll get to that soon. The language that you saw is something that's called AWS CEDAR. CEDAR is a language that released by AWS a year ago for scientific proof authorization decision. If you have a very sensitive system and you want to make sure that the authorization happen very fast, CEDAR came with a scientific proof testing framework that you can test how long your decision will take. And last is an implementation of Google Zanzibar, and we'll get to that soon with details, called OpenFGA. So the first one, what we are looking here is Rego code, is the Open Policy Agent code. One of the things about Open Policy Agent is it's multi-purpose. It's not built for authorization in application or for authorized developers to deliver cloud product. It's built to get policy decision. And that makes it a little more complex than the other alternatives. I personally super like Open Policy Agent because I know how to work with the language, but for most of the people, I would not recommend to start with Open Policy Agent for authorization because the language has some learning curve that is not easy to most developers. In the other end, Open Policy Agent is the only thing that can give you actually what I call multi-domain analysis or multi-domain policy engine. because Open Policy Agent is so generic, you can get decision for multiple types. So for example, here is just an example for use cases that you can do with Open Policy Agent, and actually product that you might know built on top of Open Policy Agent. API gateway, there are plugins. That's example con plugin. Every API gateway has Open Policy Agent plugin. Also in some feature flagging solution use Open Policy Agent to get feature flag decision. In the infrastructure, you can implement Open Policy Agent. If you're around the Kubernetes or the cloud native ecosystem, you know that many of the infrastructure stuff related to Open Policy Agent. Also, you can put it everywhere. A product that I like, a use case that I like is called Kix. Kix is an open source library that allow people actually to check their infrastructure as code static files. This is not authorization, but it's still based on Open Policy Agent. So if you think that you'll need to implement a policy engines in your system, Open Policy Agent is a great choice. If not, better go with one of the other options. The first one I'm showing here is AWS Cedar. Cedar is a language that's built for attribute-based access control. Why? Because they don't want to store centralized data. If you remember, we mentioned that in relationship-based access control, we need this centralized graph. There is option to decentralize the graph, but then we are losing the scientific proof because we have latency when we are sharing the graph. And in this attribute-based access control, in AWS Cedar, we can very easily get high-level or fine-grained attribute-based access control. I personally love Cedar because, as you saw, the language is very simple to use. It's very intuitive. It's just you look at the code, you understand what is it. It's very oriented to authorization, yet it's hard to deal with relationship data. And this is where we are getting to OpenFGA. This is the syntax of relationship in OpenFGA. What you can see here, which is, by the way, a great example of fine-grained authorization, is the authorization model of GitHub. Right? We have here all the resources of GitHub, the relationship in GitHub. So for example, a member, a repo admin. In relation-based access control, we can maybe chain roles to each other to create more relationship on our software. And when we deploy actually OpenFGA with this kind of configuration and put all our data in, right, we are syncing the user relationship into the OpenFGA engine, we can very easily get relationship-based decisions. OpenFGA has a con because it supports only relationship. It has very limited support in role-based access control, but it does not support any kind of attribute conditions. And I found that many needs attribute condition as part of the authorization system. So OpenFGA is alternative or the opposite of AWS Cedar, and yeah, OpenFGA is the opposite to Cedar, and Open Policy Agent can do everything for you. For example, at Permit, we are using internally in Open Policy Agent to model policies in RBAC, ABAC, and RBAC. But for customers who want to write the code themselves, we are recommending to start with either Cedar or OpenFGA to extend their policy with Cedar or OpenFGA. I think that was the most overwhelming part of this talk. And sorry if I'm mistaken and all this talk was overwhelming. But I think it's important to know that there are tools out there that can help you. If you want to check, there are many large companies that can tell you about what they choose, what the model they choose. Actually, I haven't any kind of link here, but if you just Google like authorization at Netflix, you find an article how they do it with OPA. If you Google authorization in Reddit, you can find an article how they do it with Open Policy Agent. So you can also read the use cases, how they solve that, and now you can solve also fine-grained authorization yourself. I also want to talk about an open source product that I am one of the maintainers of. You heard about all these policy technologies, but now you have a big step between them and implement it in your environment, right? You need to manage all the policy files. You need to manage the data into the policy engine. You need to make sure that it's all fit with the software development lifecycle. So the developers now not getting the hardest of writing many policies. I will ask you, if you are going there, just please start it on GitHub. Giving start to open source maintainer is help us to grow. So Open Policy Administration Layer, or OPAL, is actually an end-to-end authorization service that, based on Policy Engine, you can work with OPA, you can work with AWS CEDAR in it, and that's actually help you implement with one Docker file compose a whole authorization system, again, based on Policy Engine. We are going to support also OpenFGA soon. Today we are support only OPA and CEDAR. But this is a great start if you want to get end-to-end authorization service. These are actually the specification we have in Opal. Opal is built to support seamless with the software development lifecycle. So when you deploy Opal, you are configuring what is your Git repository of your policies, and Opal automatically know how to synchronize your Git branches with your policy engine that ran per branch. So for example, you can deploy Opal server and then tell them, okay, for production, track this branch of policy, and for staging this branch, and for developer environment this branch. And then at every step on the software development lifecycle, you can get only the relevant policies for this step in the lifecycle. So here I left 5 minutes, so I think it's better than go to the question, because I saw there are some. Okay.
So the most popular question was, what was your most challenging situation in authorization code development?
As an end user, or as someone who develop authorization system?
Presumably development. You're someone who develops the systems.
Yeah, so one of the main problem is incorporate these policies code systems, and this is actually what led us to develop Opal as an open source, is the incorporation with the software development lifecycle. Are there anyone here already got to work with any policy engine like OPA or CEDAR? Okay, that's surprising. Sometimes there are one or two very angry hands that raised up. One of the things about incorporating new programming languages and new technologies is how developers react, right? When developers get, okay, I think now authorization is not good, we need a new language to create policies, they say, I don't want to learn a new language, especially not an ugly one. But if we are giving them a nice developer experience, we are giving them a more influent way, we are influencing the way that they are actually. So the main challenge is developer experience. The solution is make sure it works, it incorporate. So two solutions. The first one is make sure it's incorporate with the software development lifecycle, so they do not have to create too much effort just in the process of incorporating that. The second solution for that is to make sure you minimize the touch point with other stakeholders. So for example, you should consider internal permission management portal, or use some of the permission management services out there instead of letting developers control permission themselves, because then all the time product managers, etc., will come to them, hey, change that, change that. So it's better to outsource the part of the permission configuration.
Okay, and I think we might have time for this last one. RBAC seems to be a mighty, but isn't it a performance killer, having to traverse the graph for subjects and resources for every single authorization query?
Yeah, that's a great question. Every time that people get familiar with Zanzibar, that's the first question they ask themselves. Google, that created the paper, luckily own the internet, so they don't mind. They can deploy a whole graph of all their users everywhere, and it would cost them nothing. For us, if we have, for example, multi-region application, we still need to deploy this giant graph. The solution that we found for that is do sharding on that graph. We're using eventual consistency to manage different decentralized graphs. And then what we are doing, we have a very specific subset of the graph. It's actually partial configurable what's part of the graph you are putting in every region or every part of the graph. And then by eventual consistency mechanism, you can make sure that if part of the graph is not exist, you at least know that part of the graph can change the decision. And then you can let the application, it's a little complex, but Rebak is complex, so I'm allowing myself to take the step forward. But what you can do with eventual consistency is say, you should know that there are some part of the graph that not exist here. If the decision need that part of the graph, then go to the other and shard it to the current one. So that's the solution that we find with decentralized graph, but this problem is valid. One of the main problems of relationship-based access control is getting all the graph. By the way, traversing is not the main problem. Traversing does not take time in a good modeled graph. Traversing is the less problem. The main problem is that you need to actually have petabytes of metadata. But yeah, I guess it's answer